Astronomers have never seen this powerful cosmic object before. Astronomers were shocked in 1967 when they picked up radio signals that appeared and disappeared every few milliseconds or seconds. They proceeded to call them little green men or LGMs. Some explanations since then have included pulsars, which are essentially rapidly spinning neutron stars that are the leftover debris of various different supernova explosions. A supernova is a super powerful, extremely bright explosion of a star and is essentially the largest explosion that has ever been seen by humans. Approximately 4,000 years ago, enormous amounts of energy were emitted by an intensely magnetized and extraordinarily dense object. The enormous amount of energy was pointed towards the Earth's location in the shape of a beam and was emitted every 18 minutes. After crossing the vast length of space, it landed in Western Australia in 2018 on a radio telescope and was a huge surprise to the observing astronomers. These radio waves had limited similarities to the signals that are produced by a pulsar. However, they looked vastly different from anything that has been seen before. The radio waves required a fundamentally new explanation, which despite astronomers not having any clear explanation, they ruled out aliens. But before we go further, do remember to subscribe and click the bell icon for regular updates on the latest developments in the scientific world. The latest discovery. A recent discovery has been made by astronomers regarding a mysterious flickering object in the Milky Way, our galaxy. This mysterious cosmos is one that blinks too slowly to be a pulsar, but also too fast to be a supernova, while also simultaneously shooting out gigantic amounts of energy towards the Earth thrice in 1 hour. In a statement, the researchers have claimed that this mystifying object is located approximately 4,000 light-years from the Sun, and being a strangely powerful object, it is unlike any cosmic structure that has been observed by humans. Researchers have named the object in question the GLEAM X J162759.5 to 523504.3. We will call GLEAN for short. The GLEAM appears on the Milky Way on a radio wave survey completely out of nowhere, as reported by researchers. For a short period of 60 seconds, GLEAM proceeded to brighten quite rapidly and quickly became one of the brightest objects in the entire sky. However, it also then suddenly disappeared in the darkness. GLEAM made a second appearance 20 minutes later, once again glowing steadily towards peak brightness, and then following the previous pattern, it dimmed back into nothing after a minute. Transient objects. Transient objects are objects similar to the GLEAM. They appear and disappear before the lens of our telescopes. Transient essentially represents a supernova, a dying star, or even a rapidly spinning bizarre corpse of a neutron star, which is basically a star that's already dead. As reported by the researchers in a new study, the behavior of this newfound object, however, does not quite completely fit into any of these standard explanations. This new mysterious gleam can be the evidence of the existence of a new type of stellar object that has only been a theory till now. One of the astronomers have not even dreamt of. Natasha Hurley-Walker, who is the lead study of this research and is also a radio astronomer at Curtin University in Bentley, Australia, said in a statement that this object was observed to appear and then disappear over the period of a few hours and was a completely unexpected shock to the world of astronomers. She said that for an astronomer it was significantly spooky, as there is nothing in the night sky that is known to do that. There have been numerous attempts to recapture the signal of the gleam, however to no success. Hurley-Walker, along with O'Doherty, dug through data spanning over years from the Murchison Wide Field Array (MWA) and discovered 2 periods of 71 pulses when it was on over almost 3 months. Unsurprisingly, the vast majority of other telescopes have failed to detect it. The sensitivity and the unique combination of the MWA allow it to have a wide field, which has over time helped it to pick up various unexpected objects, which other telescopes would only be able to find if they were focused exactly in the right location. The quest begins. Once this new information surfaced, there has been a quest to explain this unexpected discovery. The easiest explanation to rule out was the aliens. Another possible explanation could have been technological signals. However, they cover a very narrow part of the spectrum, and the spectrum of gleam is significantly broad. A truly staggering amount of energy is required to produce a signal to be emitted over so many frequencies, which would be wasteful for any civilization so advanced they could even do it. Hurley-Walker, which communicates with the IFL science, also ruled out the possibility of it being a slow pulsar. She said that if this was a pulsar, a magnetic field of about 100 times stronger than anything that exists in the universe would be needed for it, and would also lead to a very rapid decay. Faster pulsars can also be ruled out. While they have more power, the theory is inconsistent with the slow and bright combination that is displayed by the gleam. Another possibility that was considered but also ruled out was the possibility that two objects that were in an elongated orbit were producing bursts of energy every time that they approached each other. However, the theory was ruled out. Last light of a dying star. There are two varieties of transients. Transients that appear over a time span of a few days and then disappear several months later are known as slow transients. Supernovas are considered to be slow transients, as they are essentially dying stars that blaze brightly as they shed their outer atmosphere in a series of violent explosions, then proceeding to slow and gradually dim down as the leftover of the stellar drop in temperature. The second variety of the transients are fast transients, as they have seen to flicker on and off every few milliseconds. Objects like pulsars such as a neutron star are classified as fast transients. These neutron stars rotate at an incredible speed and flash various bright radio emissions that are generated by the magnetic field of a dead star. The moment of discovery. The discovery of the gleam was made when the authors of the study were in Australia outback using their Murchison Wide Field Array (MWA) radio telescope in an attempt to look for transients. The researchers reported that the blink off and on is too slow to be a pulsar, but are also too fast to be a supernova, with the 1 minute long brightening pattern of the gleam defying any expectations yet known to humans. The discovery of the object prompted an analysis that highlighted that the gleam was smaller than Earth's sun, but still brighter than it. According to the authors of the study, the radio emissions that were emitted by the gleam were also highly polarized. The light waves emitted only vibrated on a single plane, which suggested that the origin was an extremely powerful magnetic field. The possible explanations. The ultra-long period magnetar is a type of theoretical object that matches the characteristics of the gleam. It's basically a neutron star that is highly magnetized and also rotates incredibly slowly. The researchers said that this is an extremely rare class of object which had been predicted to exist but had never actually been observed in space before. They went on to state that direct detection of one like this was not expected by anybody, and also not expected to be quite this bright. Hurley-Walker stated the object was converting magnetic energy to radio waves in a comparatively much more effective way than anything that had been seen before. The researchers also added that there may be other explanations to explain the existence and behavior of the mysterious gleam. Another possibility is a rare type of white dwarf star, which is a dead star turned into a shriveled husk, which was not massive enough for it to explode and turn into a neutron star. This can also very rarely emit radio emissions by sucking the material of a companion binary star. A pulse like the pulse of a gleam that can be caused by such a star, with its rotating at exactly the right speed. To resolve this stellar mystery, further explanations and observations of other bands of the electromagnetic spectrum are necessary. Researchers, since the discovery of the gleam itself, are now digging into various archival observations from the MWA to spot any similar objects having ever turned up. The gleam lies off the galactic plane by 2.5 degrees, and this distance was calculated using dispersion as longer experience slows down more when passing through interstellar material. While nothing has been found to match this discovery, as reported by Hurley-Walker, the area is regardless crowded, with it being so close to the galactic plane. O'Doherty was praised by Hurley-Walker in a media conference for his search on the galactic planes.